can tell the heading. Number of arbitrary constants is greater than number of independent variables. That is, there are more A, B, C, D than the X, Y, Z. Okay, so we will have a rule governing that. The rule is you have PD of order greater than 1. That is, you have an answer in such a way that there will be more than one derivative inside. That is, it could be a second order or higher order derivative. So let's just pick some few examples. From PD from A, z equals ax plus by plus cxyb. Z equals a squared plus bxy plus cyz. So let's solve this. Now, so we are solving A. So z equals ax plus by plus cxy. It's my equation 1. Let us now put up a table. So this is my arbitrary constant. This is my independent variable. So my arbitrary constant is A, B, and C. My independent variable is X, Y. So here I can say that this is 3, this is 2. The number of arbitrary constants is greater than the number of independent variables. That means that I'm supposed to have a PD that I'm supposed to have an order of 1, meaning I'm supposed to differentiate more than 1. Okay. But since it's a function of xy, it's a function of x, so I'm going to differentiate twice. Now, because the question, this one is a function of xy, I'll differentiate twice because of this. Z is the function of xy. So the first derivative is dz dx is a plus cy, equation 2. dz dy is b plus cx, equation 3. Second derivative. The square z over ds squared, meaning I'm differentiating this again, is 0. The square z over dy squared, meaning I'm differentiating this with respect to y, 0. The square z over dx dy, or the square z over dy dx, that is, I'm having this differentiating with respect to y, or I'm having this differentiating with respect to x. They all give me one answer, C. So that is equation. Maybe I call this equation 4, this equation 5, this equation 6. Now, this is not an answer because there's an arbitrary constant. Possibly this is a trivial solution. This is an answer because there's no arbitrary constant. This is not an answer, this is not an answer because the arbitrary constant is inside. This is not an answer. But I can find A, B, C from here and put them inside this so that the arbitrary constant goes away. I know C already, so I'm okay. I can find A and B from here since I know C. I can use this C to find A, I can use this C to find B. So what happened is that case 1 puts C is equal to the squared z over the xy, dx dy in equation 2. So we have equation 2 is z dx is equal to a plus cy. So I'm putting the c here. That gives me a plus y, the square z over dx dy. So I can make a the subject. A is equal to the z dx minus y, the square z over dx dy. So I've gotten my A. I can do the same thing. I can put C into this so that I can make B the subject. So case 2. Case 2. Put C is equal to the square z over the x dy into equation 3. So we have equation 3 is the z dy is equal to b plus cx. So As I said earlier on, in the first case, we put C equals this into equation 2. Today we are putting the same C equals this into equation 3 so that we can find our B. So we have, so C, we are replacing it by this. So X is multiplying this, so X is multiplying this. So B plus X multiplying this. So we make B the subject, that is dz over dy minus X d squared z over dx dy. So now we know B, we know A, we know C. We can put it inside equation 1. We can put it inside equation 1. We can put it inside equation 1 so that A, B, C will vanish. So let us go and finish that one. So we have Z equals AX squared plus BXY plus CYZ. Sorry, AX plus BY plus CXY. So we put A, B, and C inside. So we have Z equals X multiplying A. So we have this as my A. So X multiplying A. So we have X multiplying dz dx minus Y d squared Z over dx dy. So this is my A. B multiplying Y. So this is my Y and this is my B. B is dz dy minus X d squared Z dx dy. XY multiplying C. So this is my XY. My C is this. D squared Z over dx dy. So d squared Z over dx dy. Good. So we expand and simplify. So when we expand, we will have X dz dx minus XY d squared Z dx dy plus Y dz dy minus xy d squared Z dx dy plus xy d squared Z over dx dy. This can cancel this. So what we are left with is x dz dx minus xy d squared Z over dx dy plus y dz dy as my final answer. So this is the final answer. Thank you.